To be able to tell what's the difference between system capacity, bottleneck, and actual output, let's take an example. If we have a system and we have one person, the person is A, and he's doing a job. The working hours is 8 hours, 480 minutes. Okay, no breaks. Okay, we find out that A, he needs 10 minutes per job. So the total expected output per day, is total output is 48 units per day. Okay, as a total output, 480 divided by 10, 48 units per day. Okay, assuming that no breaks and 0 scrap. Okay, this is the system capacity. Actual output is how much you have to produce. You don't have to produce 448 units per day. Actual output usually it could be based equal to the demand required, or it could be taken into consideration unavailable time per day. But capacity is the maximum you can produce if all conditions are met, if all the conditions are perfect. If we consider the same example, but now we have a second step B in a system. So A is 10 minutes per job, B is 15 minutes per job. If same condition apply, total output here is 480 minutes per day divided by 15 minutes per job. So it's 32 jobs per day. 32 jobs per day. Okay. So why we consider 15? We didn't consider 10 or 25 as 10 plus 15. I'm gonna consider this. I'm gonna show you like a small example, not related to what we're doing here. Saying if we have two people working, okay, independent to each other, but in a sequence, like a job has to go through A, then through B to finish. If A, it requires 10 minutes, and B, 15 minutes per job. If a person arrive here at 8, he would finish from A at 10 past 8, and he will finish from B at 25 past 8. If a second person arrive, he won't be able to get into A before 10 past 8, and he will finish at 25 past 8. Okay, so he need 20 past 8. So he need 10 minutes, and here he would need to 15 minutes here, so here he won't be able to get. So he finished from A at 8:20, and he gets into B at 8:25, and he finished from B at 8:40. Okay, a third person come, he will enter at 8:20, will wait till 8:30, he has to wait till 8:40, and he will finish from here at 8:55. So the first person, just do it in this way. Imagine you're a customer waiting to see person A and then to see person B to finish. Okay, so if person B is busy, you won't be able to go into person B unless he's free. So you have to wait here. So if you're standing here, outside here, so you see the first person, he left after 25 minutes, which is 10 plus 15. The second person, he left after 15 minutes and 15 minutes. So on the long run, the speed of the system, okay, the speed of the system is dictated by the bottleneck. Okay, the bottleneck, the slowest person in the system. Okay, slowest person in the system. Alright, if we consider, we're still doing the same example, so we have A and B. So this is 10 minutes, and here it requires 15 minutes per job. but the total time per day, 480 minutes per day as total time. Part of it we have 60-minute break, so the remaining available time is 420 minutes. So the output here is equal to 420 minutes divided by 15 minutes. So that would be 420 divided by 15, 28 units per day. Okay, so you could see the capacity of the system is when you have only A, so this one is very correct. The capacity of system when you have 2 machines or more than 2 machines, we have to calculate it as we see here. Okay, once we consider the time, once we consider the scrap rate as efficiency, this will not be the capacity of the system. This will be as a maximum output we could obtain from the system, but not the capacity. Okay, and then we have the actual output. It could be satisfying demand or capacity taken into consideration available time, scrap, bottleneck. Okay, so those factors the one we have here, they affect the capacity of the system. Like those values we have here as time available, scrap, bottleneck, they all affect the output we're going to obtain from the system. It won't be capacity anymore, it will be the actual output or the demand itself, as we don't have to produce amount, as we don't have to produce the amount or to get it near the capacity, but we produce as much it is possible. And I need to remind you about one thing: we always work, we always hope, we always plan to produce, to increase our actual output to reach the capacity. We always plan to let our actual output to reach the capacity. Like this value here, system capacity is a maximum. We're trying as much as possible to get this actual output closer to the capacity of the system as much as possible. Okay, I'll give you an example. Like, you improve the efficiency of the system by trying to reduce break time, unavailable time, by trying to reduce scrap, by trying to optimize the number of workers, to reduce idle time. So as much as possible you try your best to bring the actual output to the system capacity as we saw here in this example.